Hello and welcome back to the channel. I'm really glad that you came back. I'm a little bit surprised, honestly, but thank you very much. I'm glad that you're here. Today, as promised, I want to talk a little bit about the very basics of, I guess, what we would call pre-algebra. I don't want to pull the rug out from under anybody's feet. I don't want anybody to feel like they have to be a math genius in order to be able to engage with this channel. So today, we are going to be talking about adding and multiplying positive whole numbers. And we're going to dig a little bit deep into it and see how the seeds of algebra are being planted even in this early topic. So what I'm going to do now is I'm going to ask you the same question I asked my friends on Facebook. And I'd like you to really stop and think about how to answer this question. Again, there's no grade here, there's no time limit, you can pause the video. I just want you to be thinking. There isn't even really a right or wrong answer to this question, okay? So the question is, if I say 14 plus 7, the question is, how would you go about solving this problem in your head? How would you actually get, I know that the answer is 21. Like, hooray. I'm well aware that the answer is 21. But what I want to know is what goes through your mind to get you to 21. And I asked some of my Facebook friends about this, and I'm going to share some of their responses. But first, I would really very much like it if you would pause the video just for a moment or a minute or however long you need, and just think, okay, so 14 plus 7. Really think this through. See if you can put into words the actual thought process that you go through to get from 14 plus 7 to 21. How do you get from the beginning to the end? Take a moment, ready, set, go. So like I said, I asked my friends this question, and I wanted to know what goes through their minds when this happens, other than an immediate panic attack, which unfortunately was the response of one of my friends who had just a terrible time with a math teacher, and that hurts me every time I hear about that. I know that there are awful math teachers out there, and I know that they can do a lot of damage to your self-esteem. Maybe, hopefully, this video series will help get past that. I don't know, maybe. Anyway, so there is a lot of ways. There are a lot of ways that we can do this. I'm going to start with the sort of classic, sort of traditional way that I learned when I was in elementary school. You take 14 and put it on the top. You take 7 and you put it on the bottom with a plus. Right? This is how I learned it. And let's go ahead and zoom in on that. So the way I was taught to do this is I would take, okay, so 7 plus 4 is 11, right? So I'm going to put 1 down there, and then those 10 ones in the 11, I would cram them together into a 10. So I put a 1 up here in the tens place. And then I add 1 plus 1 is 2, and I get the answer of 21. This is an absolutely valid way of doing this problem. If this is your go-to method, then you are killing it. I mean, it's not the most intuitive method, I don't think, but it does have very well-defined steps. And if you are the kind of person that responds well to well-defined steps, this might be the method for you. There were several friends who mentioned that they memorized the response to that one. Like, just 7 plus 14, boom, it just pops into the head immediately. And a lot of the time, the folks who are saying that are the kind of folks who work with numbers on a day-to-day basis, but not all of them, of course. But Usually with a student, if they say they have it memorized, I will push back just a teensy-weensy little bit, not because it's wrong. I mean, I know that a cheetah can run at 55 miles an hour, and that's not something that I have to prove. I just know it. It's something that I've learned over the course of my life. So saying you memorized it is a valid response, but if you're the kind of person that has this memorized, what I would like you to do is look at the other methods as well, and just see if you can understand what other people are doing to get their response. So no shame for being the type who is able to memorize that kind of stuff. That's pretty amazing. I got a bunch of folks saying something along the lines of 21 is the next multiple of 7. And I really, really loved that answer. I'm going to go ahead and put that answer into mathy terms because it shows a very sophisticated level of understanding for concepts that are going to come up in this class later on. There's a lot of algebra hidden in here that you don't necessarily see until someone points it out. 21 is the next multiple of 7. So what they're saying is that 14 is really 2 times 7. Now, a quick note about notation. Notice this dot that I'm putting in the middle here. That is one way that you can represent multiplication. After elementary school, we kind of stopped using x's. That's a terrible x, but anyway, we stopped using x's because x is an actual letter that we use for a variable in algebra. So using an x for multiplication isn't wrong, just make sure it's very clear the difference between your multiplication x's and your x's, if that makes sense. I hope it does. 2 times 7 is 14, plus just one more 7, right? 1 times 7. Once again, that dot is multiplication. So what they saw is that if I have 2 7s here and 1 7 here, right, and I put them into a pile of 7s, how many 7s do I have? I have 3 7s, and that's 21. I love this reasoning. Now, here's something that might surprise you. When I first posed this question to myself, when I thought to myself, hey, self, how would you manage this kind of small addition? And the answer usually comes up, my fingers. 14, 15, 16, 17, 18, 19, 20, 21. Boom, no problem. Don't ever be ashamed to count on your fingers. That's literally what they're for. The reason that we have a base 10 system is because it's easy to keep track of, because we have 10 fingers, at least by default. So what would my method look like mathematically? Well, what I did was I started with the 14, and every time I raise a finger, I'm essentially adding 1, right? 15, 16, 17, 18. So I'm really just adding 15, 16, 17, 18, 19, 20, 21. 1, 2, 3, 4, 5, 6, 7. 14 plus 7 equals 21. Yeah. These are all absolutely valid ways of doing this problem. The really important thing is, can you explain your thought process to yourself, to the people around you? Does it make sense to you what you're doing? That's the really important thing. Here's another example that I saw that I really liked. Someone said 14 plus 5, because some people, it turns out, count by 5s very well. 5 is one of those kind of keystone numbers where sometimes if something is a multiple of 5, it becomes very easy to deal with, because then you can double it to make a multiple of 10. So 14 plus 5 is 19. Well, and then there's 2 left over. So you get 19 plus 2, which is 21 once again. Yes, we knew that the answer was 21 the very moment I put the problem down on the page, but the answer was never the point. And when I asked this question of my friends, I got so many incredible, amazing answers that I can't fit them all into one episode right now. I do have one more, though, that I really want to showcase because this is one of my favorites. So, one of my friends said that they take the 14 plus 7, and let's see if I can come up with the exact quote. 7 needs a 3 to complete the 10, is what they said. 7 needs a 3 to complete the 10. And I love that wording so much. What it means is that if I take 3 from the 14 and give it to the 7, that'll make 10. And again, 10 is one of those numbers that is very easy to work with because then you only have to keep track of one digit, right? So anytime you can make a multiple of 10 in your head, it can be very helpful. So if we move 3 from 14 to 7, well, then we get 11 plus 10, which is 21. And it feels like I'm being really repetitive here, but I want to make it clear that every single one of these methods is absolutely valid. Every one works. The important thing is that you understand the process that works for you and that you're able to explain it to others in a way that makes sense. The second example that I gave to my friends was a little bit more daunting. It was 15 times 6. That is a terrible 6. Let's do that again. You're a math teacher, Cunningham. So, 15 times 6, and I asked them once again to please give me their best shot at explaining their thought processes, not just telling me that the answer is 90, which it is. Again, the answer is not the point here. So once again, I would love if you would take just a minute, pause the video, take a look at this problem right up here. 15 times 6 equals 90. How would you do that in your head? How would you do that if you had a piece of paper? Take a minute. Ready, set, go. One that came up a lot looked like this. This was a very common kind of response that I got. Take a look at it for a moment. Can you see the logic here? Can you see where they were coming from when they gave me this information? What they're actually doing is recognizing a fairly fundamental law in both arithmetic and algebra, and that's distribution. We know that 15 is 10 plus 5. I'm putting that in parentheses because now we're going to multiply that entire sum times 6. And just like in the example that we have right next to me, you end up distributing the 6, and you get 6 times 10 is 60. 6 times 5 is 30. You get 90. The only difference between these two methods is that one of them uses a particular notation that has to be learned. The other one is mostly intuition. You know that 10 and 5 together make 15, and you know that 60 and 30 together make 90, so this makes sense. But as you get into more and more complex ideas, it's going to be important for us to have a common language so that we can name all of these fascinating patterns that we're seeing here. Okay, let's look at some other examples of ideas that I got when I asked this question. I like this one. One friend said, times 10 and half again. I love this one, not only because it rhymes, but also because it again shows me that people have an intuitive understanding of some of the patterns behind these numbers. Because yes, what this person is saying is that you take the number 6 and you multiply it by 10 to get 60, and then you add half of that again, because 5 is half of 10, right? You've got 10 plus 5. Because 5 is half of 10, we are going to add half of 60 to again get 90. There is one more example that I want to show you. And this friend said that it was the same thing as 15 times 2 times 3, which I'm inclined to agree with, yes? 2 times 3 is 6, so 15 times 2 times 3 is going to be the same thing as 15 times 6. Okay, haven't lost anybody yet, I hope. So what this person did was changed this 15 times 2 into a 30, right? 15 times 2 is 30, so it was 30 times 3. And I'm going to put an equals here to show that it's still the same thing as we've been working with so far. Now, 30 times 3, a lot of us will look at 30 times 3 and immediately say, oh yeah, that's 90, right? Because like 3 times 3 is 9, so 30 times 3 is 90. And that's where my mind goes. But this friend said, yeah, that 30 times 3 is 30 plus 30 plus 30, and that's 90. And I said, yeah, that's right. When you are multiplying something by 3, that is effectively the same as adding it to itself 3 times, right? 30 times 3 is the same thing as 30 plus 30 plus 30. Now, that's not where my mind went. That's not how I thought about it. But I thought it was phenomenal that that's how they did it. And that's all I've got for this video. Math is a foundation built on very simple ideas that gain complexity as you gain proficiency. As you begin to learn more of the vocabulary, we will be able to put words to concepts that you might have a hard time fathoming now. It's easy to see 14 plus 7, right? I could have a stack of bricks where there are 14 and 7 of them, and I can just count them up, right? That's something I can see. That's something I can touch. Once we start talking about negative numbers and rational numbers and irrational numbers and all that sort of thing, then it starts to get a little bit hairier. But the good news is the rules that we learn here with these normal positive whole numbers, these rules are going to apply to all of the real numbers, regardless of how strange they may seem in a problem. I am going to go ahead and leave links to a couple of Khan Academy exercises down in the description, just to give you an idea of how this channel is going to work and how you might want to interact with it. If anything about this video confused you, that's totally okay. You can ask me questions in the comments, or you can check out the supplementary videos that I should be linking up there right about now, and hopefully that'll help you out. In the next video, we will be talking about negative numbers and subtraction. Spoiler alert, subtraction isn't really a thing. It's really just addition again, but this time with negative numbers. See you then.